Hi guys, Tin Man again. Just doing a bit more work on the system that I posted yesterday. Now I've made a few changes, put a bigger cap, better to swallow any voltage that's going in there. I have a 2.5 volt LED hooked across the probes as well as our meter, which is set to DC voltage also. Now someone suggested I use an AC meter as well, or a meter set to AC, and see what that reads, which we've also got up there. So we've got our AC and our DC coming directly off of the cap, from the cap into our two probes which go into the water, and also our 2.5 volt LED. Changes I've made here: I've put two spirals of copper wire into the water, which come into the AC side of a bridge rectifier, and then from that bridge rectifier we're going into a cap that is a 150 volts, 150 UF at 450 volts, and I have a 80 volt neon across the two posts on the cap as well. Now the idea is to pump the cap up until the neon comes on, which will be around 65 to 70 volts is enough to start to fire it up, and then once that has reached that voltage we will remove the neon and see how high our voltage climbs. Now the frequency I'm using is about 1.1 kilohertz. Anything less or anything more draws more current from the run battery and produces a lot less output from our bridge rectifier. Now that frequency 1.1 is quite interesting because it's a square division of the frequency of hydrogen, which is 42 megahertz thereabouts. Same setup as yesterday, same effect, everything is fully charged when the system is running. So had to put some gloves on to adjust it to the right frequency, and that's pretty much well it as it stands. So we'll fire it up now. We have 1.3 volts in our little cap at the moment. Our big cap's got 0.54 volts in it, and of course the AC is reading nothing. So we'll start it up and we'll see what happens. So as you can see, our DC voltage is coming up. Now our AC voltage is reading 32, 31, 30 volts. So I'm not sure why an AC meter will be reading DC voltage off a cap. And it's a large cap, 10,000 microfarads, 63 volts. As you can see, our 2.5 volt LED is fairly dull because it only has 1.8 volts going across it. So now it's time to hook up our two probes that are in the water to the cap, and we'll see what happens to this voltage. Okay, so I'll try and get that in so you can see the voltage and the neon come on. Like I said, around 65 to 70 volts it should start to fire up, and there we go, and that will hold that cap steady there at the moment. So a little LED is definitely not getting any more voltage than what the meter is reading. Now the bubbles are starting to form on the two stainless probes out the back. Not sure if you can see that, but they are starting to form. But anyway, what we're going to do now is remove the neon, and we'll just see how much voltage we're getting out of the water. While that's climbing, we're pretty steady at about 1.82 volts. Our AC is now saying 18.5. A little 2.5 volt LED hasn't exploded, so that's a very good sign that that's all the voltage that's going in there. Unless of course we have a DC voltage and hiding within that somewhere is some other sort of voltage. If it was AC, I would have thought that would be reading a lot higher than that. We're now just past 250 volts in that cap. Of course our back EMF is charging that battery. Now this is also interesting as well, because this battery actually is charging a lot more, and then that is going down, letting them sit overnight. This had gone up about 0.5 of a volt higher than that went down, so, and they're identical batteries. But we won't get into that side of it. As we know, batteries can play tricks. We've now just passed 320 volts in that cap. And I can assure you that voltage is in that cap, as you would have seen. The neon certainly wouldn't have lit up if the voltage wasn't in the cap. Caps are very good for measuring peak voltages, because they will build up to the peak voltage that a system is putting out. So we're getting quite a few bubbles there on that back probe now. Like I said, it's definitely not a hydrogen production machine, but what is interesting is that it's actually making it off of one single wire. So we've just passed 400 volts. It is only a 450 volt cap, so now most people would use a resistor to discharge them, but that's no fun because you don't get a big bang. So I hope you're ready for the big bang. That most certainly was in there, and we didn't completely discharge it. It's still got 100 volts in it. And we discharged it then. It is only a small cap, but it certainly builds up quite quick, considering that we're only drawing whatever it is that's in the water. It may even have something to do with the water being vibrated at that frequency. I do not know. I have to do a lot more research and a few more experiments to work out what's going on. But maybe there are some guys out there that do know what is actually happening. So what I will do is I will draw the complete system up, and I will post it on our forum, and probably under solid state charges, because as you seen yesterday we can charge batteries with it. It's by no means a high current output coming out of there, but there is certainly some high voltages coming out of there. As you can see, that big cap's bleeding down. Our LED has gone out. So that's where I'm at the moment. Yeah, somehow we're getting a very high voltage out of the water, and that's something I'm going to look a little more into. Alright, thanks for watching, and I'll see you next time. Cheers from Tin Man.